In Chapter 5, we considered the basics of the time value of money by considering what happens when we try to move a single cash flow around in time. In this first presentation from the Chapter 6 material, we look at present and future values of multiple cash flows. And in essence, what we do is use the formula for single cash flows multiple times to arrive at either a future value or a present value. And the best way to discuss this is to just get into some examples. So the first example regards a future value calculation, and the setup is as follows. You currently have $7,000 in a bank account earning 8% interest. The implication here being that means 8% per year. You think that you will be able to deposit an additional $4,000 at the end of each of the next 3 years. How much will you have in 3 years? Well, what we need to do is recognize that there are a total of 4 cash flows that we need to move out to time equals 3. So the first cash flow happens today, which is time equals 0. The amount of that cash flow is $7,000. And the time difference between time equals 0 and time equals 3, which is when we're interested in calculating the future value, is 3 compounding periods. So we take our $7,000, multiply it by 1 plus the interest rate of 8% per year, compound it for 3 years, and get a future value of that $7,000 payment is equal to $8,817.98. The cash flow that takes place at time equals 1 is $4,000. The time difference between time equals 3 and time equals 1 is 2, so we have 2 compounding periods at 8%. So the future value at time equals 3 of the cash payment of $4,000 at time equals 1 is equal to $4,665.60. Similarly, the time difference between the cash flow at time equals 2 of $4,000 and our desired future value is 1 period. So we have 1 compounding period at 8%. 4,000 times 1.08 is equal to 4,320. And then the value at time equals 3 of a cash flow of $4,000 is just equal to $4,000. There is no compounding or interest effect. So in order to calculate the future value of those 4 cash flows at time equals 3, the total value that I would have in my bank account at time equals 3 is the sum of the 4 amounts, which equals $21,803.58. The second example also involves future value of cash flows. And in this case, what we've got is, suppose you invest $500 in a mutual fund today and $600 in 1 year. If the fund pays 9% annually, how much will you have in 2 years? So what we need to do is to take the payment that happens at time equals 0, the $500, and we need to compound it by 2 periods at a rate of 9%. So we take 500 times 1.09 squared. And then we have the $600 payment that takes place at time equals 1. We're interested in what it's going to be worth at time equals 2, so we compound it by 1 period by multiplying by 1.09. When I add the sum of those 2 factors together, I get $1,248.05. Now let's take this one step further. How much will you have in 5 years if you make no further deposits? And there's actually 2 approaches that we could do. We could do a similar way that we did to the calculation above. But in this case, what we have is a $500 payment that is going to compound for 5 periods at 9%, because we're interested in what is the value at time equals 5. Then we'll have the $600 payment that will compound for 4 periods, so we take 600 times 1.09 to the 4th, add that together, and we get $1,616.26. The second way is we could take advantage of this calculation of what the value at time 2 is. So we know that these 2 payments of $500 and $600 at time equals 2 are worth $1,248.05. Well, if I leave that money deposited in my account and allow it to compound for 3 more years, albeit time equals 5, and I do that at an interest rate of 9%, so I multiply $1,248.05 by 1.09 to the power of 3. When I do that, I get $1,616.26, which is the same answer, which drives home a really important point. When we're talking about moving cash flows around in time, it really doesn't matter what approach you take. As long as you do the calculations correctly, you will get the same answer. Now we're going to shift gears a little bit and we're going to start to think about present values. So in these cases we have cash flow lump sums that are going to take place in the future, and we're going to want to bring them all back today. So what we'll do is make multiple use of the present value formula. So the example here says you are offered an investment that will pay $200 in 1 year and will pay $400 the next year and then $600 the year after. So we have and then $800 at the end of the following year. So in terms of time references, what we have is a $200 payment at time equals 1, a $400 payment at time equals 2, $600 payment at time equals 3, and an $800 payment at time equals 4. And if we can earn 12%, and that implies 12% per year on similar investments, how much is this investment worth today? So in order to do that, very often, and what I'm going to show you in the tutorials that we do live, is that timelines are very often a good way to look at what is going on. So as I described before, at time equal 1, 2, 3, and 4, we have 4 cash payments of $200, $400, $600, and $800. Well, in order to figure out the present value of this $200 payment, I need to discount it by 1 period. And I do that by dividing by 1 plus the interest rate to the power of 1. So I divide by 1.12. And similarly, for the cash payment at time equals 2 of $400, in order to calculate its value at time equals 0, what I do is I take $400 and I divide it by 1.12 to the power of 2, because I've got 2 compounding periods. That is, I've got to bring it back 2 periods in order to get there. So I end up with a value of $318.88. And I can do the same thing for time periods 3 and 4 and end up with a present value of those 4 cash flows is equal to $1,432.93. And what that's saying is that if my required rate of return is 12%, then I am entirely indifferent between receiving the value of $1,432.93 today or the promise of future cash flows of $200, $400, $600, and $800 in each of the next 4 years. So let's take a look at the formulas and how we would go about doing that. So as I said before, the year 1 cash flow brought back to today is just equal to 200 divided by 1.12. Similarly, the cash flow, for example, at time equals 4 of $800 is equal to 800 divided by 1 plus the interest rate, 1.12, compounded by 4 periods, because that's the time difference between time equals 4 and time equals 0. And when I add each of these 4 present value amounts together, I get a total present value of $1,432.93. Another example on present value of multiple cash flows. Let's say we're considering an investment that will pay us $1,000 in 1 year, $2,000 in 2 years, $3,000 in 3 years. And if we want to earn 10% on our money, how much would we be willing to pay? Once again, we're finding out what is the price today of the promise of those future cash flows. We will use the present value formula 3 times and then add the 3 results together. So the present value of the $1,000 payment that takes place in 1 year is equal to 1,000 divided by 1 plus the interest rate, or 1.1, to the power of 1, and that's just equal to divided by 1.1. When I do it, I get $909.09. The present value of the $2,000 payment that happens 2 years from today gets discounted by a factor of 1.1 squared, giving me a present value of $1,652.89. And similarly, the $3,000 payment gets discounted by 3 periods by dividing by 1.1 cubed, and that gives me a present value of $2,253.94. I add each of the 3 single amounts together to get the present value of the 3 cash flows.